first point, that is a work is equal to force into displacement. But when the force and the displacement both are in the same direction, we apply the force on that object get displaced. Here force and the displacement both are in the same direction. Then formula for the work is F into S. But the second case is when we apply the force on the object and the object get displaced, these are not in the same direction. Then what is the formula for work? Here consider one toy. Here anybody apply the force on this toy. The string is connected to that toy. Then that force is applied in this direction. On that toy, the force is applied in this direction. But how this toy get displaced? Displacement is occur in this direction. At this direction, we apply the force. Displacement is occur in this direction. In this direction, that toys get moved. Here, the direction of force and the direction of displacement is not same. Here, the direction of force and the displacement both are same. But in this case, the direction of force and the direction of displacement is not same. Then how will calculate the work? How will you calculate the formula for the work? So here displacement is occur in this direction. Then we have to calculate the formula for work done. In case of where the direction of force and the direction of displacement is not same. Here direction of force is this, direction of displacement is this. Then we know that work is equal to, here when object get displaced in this direction, some forces act on that object in this direction also. So let's consider that force, that is a F1. F1 forces act on this object in this direction and the displacement is S. Then we say that W is equal to F1 into S. But here we not know that the value of that F1. Here we have to calculate the value of F1. Why we consider here F1? Because the object is displaced in this direction. So when object get displaced, some forces act on that object in this direction, and this force we consider here F1. Here this force and F1 is in a same direction, so that W is equal to F1 into S. But here we have to calculate the value of F1 in terms of F. Then we calculate the formula for work for a force and the direction are not in a same direction. So let's consider here, draw one perpendicular on that line, and therefore perpendicular line is present, therefore this angle is 90 degree. Here force and the displacement, one angle is present between that force and the displacement. This angle is, we can say that theta. Any angle is denoted by letter theta. Theta, it is a Greek letter. Then you not know that trigonometry in a mathematics or in a geometry, we study the trigonometry in this standard, 9th standard. Then here that a theta, here we calculate the cos theta. Cos theta is equal to, when we apply the cos theta in this triangle, when the angle is right angle triangle, then we apply the trigonometry and in this triangle. In that triangle, it is a 90 degree. So we apply the cos theta. The formula for cos theta is equal to, adjacent side. When we label that A, B and the C, the formula for cos theta is AB divided by hypotenuse. What is meant by hypotenuse? The line in front of that 90 degree triangle, it is called as hypotenuse. That AC, it is a hypotenuse. So let's put the value. What we'll get? AB is equal to S and the AC is equal to F. So cos theta, we get the value of, this is a F, F1 and the F. Here we get the value of F1. F1 is equal to F cos of theta. We get the value of F1, and this value, this is a required value. We have to calculate this value. F1 is equal to F cos theta. Call this equation number first. Call this equation number second. Put equation second in equation 1. Then what happened? Put this value of F1 in this equation. W is equal to, what is the value of F1? F cos theta into S. So this formula we also write as a W is equal to Fs cos of theta. We get the value of this W. W is equal to Fs cos of theta. When we use cos theta, when the force and the displacement not in a same direction. When these two are in the same direction, simply use this formula. But the force and the displacement not in a opposite direction or any other direction, then we use this formula. W is equal to Fs cos of theta. Means in between force and displacement any angle is present, then we calculate the work by using this formula. W is equal to Fs cos of theta. So